Hello, I'm going to share our presentation at the Poultry Science Association Annual Meeting 2020. The title of this presentation was Effect of the Inclusion of Enzyme-Treated Soy Protein, HPIV start, in starter diets of two different amino acid density feeding programs on performance of broiler chicken. As you know, soybean meal has several anti-nutritional factors that may damage the performance of our chicken. The main anti-nutritional factors in soybean meal are trypsin inhibitors, soy oligosaccharides, and the antigen beta-conglycine. As you can see on this slide, trypsin inhibitors, for instance, have a negative effect on the weight of broiler chickens. The higher, as you can see here in different colors, the higher the content of trypsin inhibitors in the final compound feed, the lower the body weight of chickens. Likewise, stachyose, one of the main oligosaccharides in soybean meal, indigestible oligosaccharides, has also a negative effect on the growth of chickens. The higher the content of stachyose in the final compound feed, the lower the growth of our chicken. Based on that, we ran a trial with the objective of evaluating the live performance of HPIV start from Hamlet Protein in Denmark in the startup period from 0 to 14 days at two different amino acid densities, 88 and 100% of the genetic recommendations compared to control groups from 0 to 49 days. We ran this trial at the Poultry Research Center of the University of Georgia and used 1,104 COP 500 male broilers. They were distributed in 48 floor pens with 23 birds per pen. Here you can see the experimental design. It was a factorial design with two main effects. The first effect was amino acid density. We had two amino acid densities, 100% and 88%. So treatments 1 and 2 had 100% amino acid density, whereas treatments 3 and 4 had 88% amino acid density. The second main effect was the inclusion of HPIV start, a product with a very low content in anti-nutritional factors. It's an enzymatic treated product in the starter diets at 5%. So treatment 1 and treatment 3 did not have any HPIV start in the starter diets, whereas treatment 2 and treatment 4 had 5% HPIV start in the starter diet. With regard to the grower and finisher diets, treatment 1 and treatment 2 had the same grower and finisher diets with 100% amino acid density without any IV start during these periods. And treatment 3 and treatment 4 also had the same grower and finisher diets with 88% amino acid density and without any HPIV start. We had 12 replicates per treatment and 23 birds per replicate. You can see here the composition of the treatments 1 and 2. On the left side, treatment 1, and on the right side, treatment 2, both with 100% amino acid density. You can see here that treatment 1 had 33% soybean meal, whereas treatment 2 had 27.6% soybean meal only, plus 5% HPIV start. So part of this soybean meal was replaced by the product HPIV start, this clean product, trypsin inhibitors and oligosaccharides and beta-conglycine free product, reducing, as we will see later, the content of these anti-nutritional factors in the diet. Likewise, you can see here the composition of treatment 3 on the left side and treatment 4 on the right side, with IV start, treatment 4, or without IV start, treatment 3. So in treatment 3, we had here 27% soybean meal, whereas in treatment 4 we had 21% soybean meal plus 5% HPIV start, an enzymatically treated product with a very extremely low content of anti-nutritional factors. Both treatments had 88% amino acid density. And here I'm showing the nutrient composition of the experimental starter diets. On the left side, we have the diets or the treatments with 100% amino acid density, treatment 1 and treatment 2. Of course, they had similar amino acid profile, and they were isoenergetic and isocaloric and isoproteic. Sorry. With regard to treatments 3 and treatments 4, they also were isoenergetic and isoproteic, and they were supposed to have similar amino acid content. So the amino acid density in this case was 88%. With regard to the study timeline, birds and feed consumption were weighted on days 0, 14, 28, 35, 42, and 49. And data was analyzed following factorial analysis, and in case that there was any significant interaction between the two main effects, then means were compared by using Takis test. Let's have a look at the results, and we start with the content of anti-nutritional factors in the starter diets, in the experimental diets. And as you can see here on the top, we have the diets with 100% amino acid density, and by replacing part of soybean meal by 5% HP-IV stat, we reduce trypsin inhibitors, oligosaccharides, and beta-conglycinin by 10%, 16%, 17% respectively. Also, in the case of the two diets with 88% amino acid density, T3 and T4, we reduce trypsin inhibitors, oligosaccharides, and beta-conglycinin by 12, 20, and 22% respectively. These are normal reductions we usually observe in the market in the field when replacing part of the soybean meal in starter diets by this clean soy product, HP-IV stat. So between 15-20% reduction is quite normal. Let's move on to the performance results, and we start with the starter period from 0 to 14 days. As you can see here, there was a significant interaction in between the two main effects, amino acid density and inclusion of HP-IV stat in the starter period. And that's why we look at the treatment results, treatment by treatment. You can see here that there was no significant difference between the two treatments with 100% amino acid density. With or without IV stat, they resulted in similar body weight gain, 1.03 pounds per bird or 1.01 pounds per bird respectively, and similar FCR, 1.2 and 1.19. However, when we look at the two diets with 88% amino acid density, we do observe significant differences. We see that the birds that were fed as IV stat supplemented feed resulted in lower body weight gain, 0.86 pounds versus 0.97 pounds, and higher FCR, 1.33 versus 1.24. I must say that we didn't expect this difference and this negative effect here. We have run many trials with HP-IV stat in different locations, in different countries, under different conditions, and we usually do not observe any difference at this early stage. That's why we wanted to figure out what happened here, and we found out that the content of lysine in this diet with IV stat was about 10% lower than in the control diet in T3, which could explain these differences in performance. And this lower content on lysine could be due to any issue, we don't know, during the manufacturing process, which did not happen in the manufacturing process of T1 and T2, because these two treatments, they had similar amino acid content as it was expected. However, if we look at the next period from 14 to 28 days, we see that there was no interaction in body weight between the two main effects, and we saw a significant effect due to the amino acid density. So 100% amino acid density resulted in 2.74 pounds, whereas 88% amino acid density resulted in 2.63 pounds. However, FCR, we did see differences in FCR, and here we saw a significant interaction. And again, there was no difference between the two treatments with 100% amino acid density. However, there was a significant difference between the two treatments with 88% amino acid density. But this time, it happened the other way around. So the birds with HP-IV stat in their diet resulted in better FCR 1.47 compared to control birds T3 with 1.51. So we see this change as a kind of compensation, to compensate what had happened during the previous period, during the starter period. Actually, when we move on to the next period, 28 to 35 days, we don't see any interaction here. We didn't observe any significant effect on body weight, and we only observe here a significant effect due to amino acid density on FCR. So birds fed 100% amino acid density resulted in significantly lower FCR than birds with 88% amino acid density. We didn't observe any significant effect on FCR by the inclusion of HP-IV stat in the startup period. However, here we start seeing certain numerical improvement, 4 points here. It was not significant, but as you can see in the next period from 35 to 42 days, that initial improvement that we observed in the previous period becomes here significant. And we see here that the inclusion of IV stat in the starter diet did have a significant effect or a significant improvement both on body weight gain and FCR. So HP-IV stat supplemented diet resulted in a growth of 1.5 pounds per bird, whereas the control diets without IV stat in the startup period resulted in 1.38 pounds during this period, between 35 and 42 days. And the same for FCR. So HP-IV stat supplemented treatments showed an FCR of 1.92, whereas the control diets without HP-IV stat in the startup period had an FCR of 1.99, and it was significantly different. And during the last period of this experimental trial, we observed again a significant effect of the inclusion of IV stat in the starter diet during this period, between 42 and 49 days. And we see that birds with IV stat grew 1.01 pound per bird during the last week of the experiment, whereas birds without IV stat in the starter diet grew 0.9 pounds per bird. And this difference was significant. With regard to the other main effect, amino acid density, we saw also here a trend, but no significant difference. Regarding mortality, FCR, we see here that there was no significant difference during the last period, 42 to 49 days. However, if we look at the overall period from 0 to 49 days, we see that there was no significant interaction between amino acid density and HP-IV stat, which means, in other words, that regardless of the amino acid density in our diet, IV stat will have an effect on our birds. And as you can see here, if we look first, we look the effect of the amino acid density, we see that the amino acid density had a positive effect on both mortality adjusted and body weight adjusted FCR, body weight adjusted for 7.5 pounds. And we see that, however, the density, amino acid density, did not have any effect on body weight gain during the overall period from 0 to 49 days. So 100% amino acid density treatment resulted in 7.43 pounds per bird, whereas 88% amino acid density treatments resulted in 7.41 pounds per bird. Let's have a look at the effect of HP-IV stat. And here we see a significant effect of the inclusion of HP-IV stat on the FCR during the overall period, both mortality adjusted FCR and body weight adjusted FCR. We see that the mortality adjusted FCR was reduced by 2 points here, significantly reduced, and body weight adjusted FCR, adjusted for 7.5 pounds, was reduced by 5 points, 1.75 for the treatments without HP-IV stat and 1.7 for treatments with IV stat. Furthermore, there was a trend with regard to body weight gain, and we see here that HP-IV stat supplemented birds grew here 7.59 pounds per bird, whereas birds without any IV stat in their starter diet grew 7.28 pounds per bird during the overall experimental period. So, in conclusion, we can say that the inclusion of HP-IV stat from Hamlet Protein in broiler starter diets at 5% reduced soy anti-nutritional factors by 10 to 17% and 12 to 22% in 100% and 88% amino acid density diets respectively. The positive effect of the above-mentioned nutritional factor reduction in starter diets was observed from day 35 onwards. That's why we call it carryover effect. We feed birds with these low anti-nutritional factors soybean, which is HP-IV stat, so we reduce the content of anti-nutritional factors in the startup period, and we observe this investment in the startup period later on, from day 35 onwards. That's why we call it carryover effect. There was no interaction between HP-IV stat in the starter diets and amino acid density on performance of broiler chickens at the 3 commercially significant market ages, 35, 42, and 49 days. In other words, regardless of the amino acid density in the diets, IV stat does have an effect on the performance of our chickens. So, replacing part of the soybean meal in the starter diets with 5% HP-IV stat improved mortality and body weight adjusted FCR by 2 and 5 points respectively on day 49. High amino acid density in diets for broiler chickens during the entire breeding period also improved performance of broiler chickens. Thank you very much.